is area of a triangle. We are on page 132 in our textbooks. Let's take a look. I hope you're already beginning to understand and realize from our previous exercises that a triangle very frequently is a half of a rectangle, right? We have one half and another half. Therefore, let's see what we can do. For triangle A, we have a base which is similar to length and height, which is what we typically think of a width. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So base equals to 6 and height equals to 5. Now, what would be the area of triangle A? Well, typically for the rectangle, we would say it's 5 times 6. But we need to half it. We need to half this area because this triangle is a half of a rectangle. So we multiply by a half. And therefore, 5 times 6 is 30, and half of that is 15 square units. Let's take a look at triangle B. Again, we have a base which is equivalent to the length of a rectangle. 1, 2, 3, 4, 5, 6. And a height. 1, 2, 3, 4, 5, 6. And a height equals to 6. Now, if you think of this triangle as a half of this rectangle, right? So we have one half. And if we think of the second triangle as a half of this hosting rectangle, therefore is a half. Therefore, what we can do is we say 6 times 6, right? That would be the total 36, length times width or base times height. But we need to take a half of it. Therefore, it would be 18. And finally, let's take a look at this triangle. Again, we can think of this to be the hosting rectangle. And watch, let's calculate the base. 1, 2, 3, 4 equals 4. And the height, the length, 1, 2, 3, 4, 5, 6. This is a 6 by 4 rectangle. Well, let's think of this. We can split it into a few parts. It will be showing on a different pictures, and we can fold it in. We can fold it and pack it neatly into this rectangle. So again, we have 6 by 4, which is 24, but we need to take a half of it because a triangle is a half of rectangle. Therefore, it becomes simply 12 square units. Let's move on. Let's look at the next page. Check this out. The following page. The area of a related rectangle is, they are solving these examples. So let's take a look at B. Notice how we can take this piece and pack it right here. And notice how we can take this piece and pack it right here. And all together, the area of this entire triangle B can be neatly packed into a half of a 6 by 6 square, which would give us an area of 18. A half of this triangle is a half of a related rectangle of 30, which would be 15. That's our half. And let's take a look at triangle C. Notice how we can neatly pack this little piece right here and this big piece right here into this spot. And again, we have a half of a related rectangle. Half of 24 is 12, which is exactly what we got on page 132. Now look at this triangle D. It's a totally slanted triangle. Again, let's figure out the base. 1, 2, 3. Base equals to 3. Let's take a look at the height of a related rectangle. 1, 2, 3, 4. 4. 3 by 4. The whole rectangle would be 12. But we realize now that triangles are a half of a related rectangle. Therefore, we take a half of 12 and we get 6. My friends, I hope it's starting to make sense. Let's derive the formula for the algorithm, the steps of calculating area of a triangle. We have base times height of a related rectangle, but then we have to take a half of it to find the triangle, and therefore the area of a triangle is base times height divided by 2, or half of base times